and welcome to another Unity 5 tutorial. Today I'm going to continue on the one that I created to show you how to make a procedural blocky mesh. So this is the tutorial from the previous video, and we can click on these blocks and add another block. So the idea is to try and optimize the Minecraft tutorials that we've been working on by using a procedural mesh instead of a whole bunch of individual blocks. So this is currently combining each block that we add into a single mesh. Now, the issue with using combined mesh and having a single mesh is that it only allows you to have one texture on it. So this one here, if I just stop this, the cube that we start with has this green shaded mesh on it, and the cubes that we're adding to it are actually this grey cube here. But when the grey cube is added to this green one and the meshes are combined into one, it takes on just the single initial texture or material, which is quite unfortunate if you want to have a whole heap of blocks that have different textures on them and combine them into one. So what we have to do is play around with the UV values, which is where I guess procedural meshes start to play with your mind a little bit, but I'll go through this slowly and hopefully it will make sense for you. So first of all, I'm going to bring up a little illustration, as I do, to talk about UVs. So what we're going to do is use a texture atlas. Now, a texture atlas is a single texture that has all of the other little textures that you want to use in it, so that when you put it into Unity, it's going to be very optimized as far as each thing in the world can share the same material, which means a lot less draw calls. In fact, it only means one draw call if you've got 10 objects that share the same material, which optimizes things greatly. So let's use this texture. So I got this from planetminecraft.com, and it's 128 by 128 in size. And you can see that all of the textures that you'd want to put on a block in Minecraft are included in this texture atlas. Now, a texture is spread over a polygon like a tablecloth. So when you do it by default, the whole thing is matched to your polygon. And the UV values are like X and Y coordinates on a texture. So this part of the texture down this bottom corner is 0, 0. And this one up here is 1, 1. And the UVs always range from 0 to 1 in size. Okay, now this texture here has 16 block textures running up the side and 16 across the bottom. That makes this position here in this texture atlas 0.0625, which is 1 divided by 16. So that gives you that point there. And then this point here would be 0.125. Now you can calculate this by constantly adding 0.0625 onto these as we go up. And if you wanted to use this entire texture atlas, then you might want to pre-calculate what all these values are up here before you start working, just so that you know what they are. We're going to work just with a few of these textures to start with. So let me just show you what is happening back in Unity. Let's go back to Unity. Okay, now just ignore these blocks, and I'm going to create a, let's see, a plane. Okay, didn't want it that big. Find it in here and just make it a little bit smaller. I want to try and keep it square so you get the idea, and I'll just move it up a little bit there. Okay, so here is a plane, and if we grab that material, that texture I've got here, and just put it on that, there you go. You can now see that it is spread over that entire plane. And I'll just rotate and move the camera for you so you can see that a bit better. Now you can see that material over the entire plane. If you want to grab just a little part of this material, so one of the block textures, and put it over the entire thing, then you need to work with those UV values that we calculated, so the smaller ones. If we have a look at the material that has been created on this plane, and check out these tiling values here, you can see that the X is 1 and the Y is 1, and that is stretching that entire texture over that surface of the plane. If we now restrict our X to 0.0625 by 0.0625, we get this block texture that was down in the bottom corner. I'll just switch back and show you. Okay, this one here. Because we're going to stretch from 0, 0 to 0.65, 0.65, which will be this point here, because this is 0.625 in the X and the Y direction. So we grab that tile there. Now, if we wanted to put this slate or stone texture here onto our cube, then the size of the tile is still going to be 0.0625 by 0.0625, but it's going to be offset by 0.625 because it's going to be offset by one tile, and then it's going to be one tile in size. This orange one here would be offset by 2 tiles, but it would still be 1 tile in size. So if we go back into Unity and offset that particular texture here by the same amount, 0.0625, we now are picking up that little section of the texture that has that stone grey colour on it there. All right, now just one more example. If I go back to my sketch again, let's have a look at the grass one. So this grass one here is right up the top. It's still the same size as a tile, but its offset in the X direction is 0 because it's starting on the very edge. But in the Y direction, it is 15 tiles up. So it's basically 1 minus 0.0625, which if I just really quickly calculate on my calculator, 1 minus 0.0625 is going to be 0.9375, this point here. Okay, so just to check that, if we go back into Unity, and our offset in the X, we're going to have 0, and we're going to make this 0.9375. There we go, and that gives us our grass. So now it's pointing to that particular texture. Now, what these tiling and offset values are doing are playing around with the UVs of the surface. The issue is, though, once we start putting an entire texture for a whole bunch of different blocks, is that you can't rely on this tiling and offset. The tiling and offsets work for the entire mesh that you're working with. So if you recall a plane, if we can just get in here, you might be able to see this plane is not a single polygon. It's made up of a whole bunch of polygons. And so Unity's doing a lot of its own UV calculations in the background when we put a single material onto a complex object. That basically means that we can't control what's on all of our little single blocks in a procedural mesh using this tiling and offset values, because it's going to really muck up what's happening, because it's this sort of like globalizes those values. So it's just not going to work. Okay, you're still going to end up with exactly the same looking texture on every single block. So we have to dig around in the code and assign our own UV values. Okay, so let's get started doing that. Let's remove this plane that I just created because we're not going to be using that. And we will leave that little grey cube there. Let's just move it over here for now. Okay, so I've created a material called block mats, and on that I have put that terrain texture, or the texture atlas of all those Minecraft blocks that I just showed you, in the albedo, so it's up here. Now the tiling and the offset is the default, so it's 0, it's 1, 1, and 0, 0. We can't play around with those values, as I said before, in here. So we're not going to do it in here. Right, so we're going to grab that block mat and we're going to drop it onto this block. Okay, so this is our foundation block, which has here the build block mesh script on it. So let's just call that something else, foundation block. It's the only block in this code that will have that build block mesh on it, because this is the one that keeps combining all of those blocks together into a single mesh, and we don't want that on all of the blocks. What we are going to do though with this grey block here is we're also going to put this block mats texture on here. So all of the blocks we're working with are going to have exactly the same material on them, which means they have the same texture. And when you're not playing the game, they're going to look like this. So the UVs are spreading out between 0 and 1. Right, now to restrict the UVs on these blocks of what you're actually seeing of the material, I've created this set UVs script, and I'm going to dump that onto this block here, and I'm also going to put it onto that block there, and I'll show you what it's doing. Let's go into this code. So this is set UVs, and it's got a lot of repetitive code in there, and we'll just start at the top. Okay, so it's actually going to calculate the UVs for you so that you don't have to do what I did before, which was find out that it's 0.0625 and then count how many blocks that you've got in the texture. So you only have to give it the pixel size. In this case, the pixels for each of those blocks is 16 by 16. And the tile position. Now that grey slated color tile is in position 1, 1 in that texture atlas. We're going to start counting from 0, 0 in the bottom corner. So that makes that 1, 1. Okay, and then we're going to calculate the range of the texture inside of that texture atlas, so where that whole block goes from. And we're going to use our min and max for U, which is our X direction UV, and the min and max of the Y, which is the V of the texture. Now let me just show you these values here back again in my illustration. So what we're calculating is, if we wanted to put, let's say we're going to use this green one, we're going to calculate this value here, this value here, this value here, and this value here, so that we can spread that little bit across the entire surface of our block. And that's what those calculations are doing. So this is your U min, V min, and this would be your U max, V max value. Okay, so back to Unity. Now what that does then is it assigns the UV values that we want to the particular vertices on this block. Okay, so there's 24 vertices in a cube, in the default Unity cube, and you can count them if you like, but trust me, we're going to put them all into a vector array with all the different combinations of UMin and VMin, Umax and Vmax that you need, which are all down through here. Now, how did I know what order to give these values? Okay, what I did was I actually grabbed a default Unity block and I ran a debug log over all of the UVs that existed in that block, and that gave me the order that Unity wants to work with your UV values. And if you have a look down the bottom of my code, these are the default values for a texture that is spread across the entire surface. And so you can see the 0 zeros and the 1 zeros in here. And basically it's just a matter of wherever there was a 0, it becomes the U min. Wherever there was a 1, it becomes the U max. And the same for the Y one. So this is the V min, and this is the V max for the 1. So I just replaced those with our new UV values. And then once you've created this UV texture, this UV array of vectors, then you can assign it to the mesh using this code here. So we grab the mesh filter, and the mesh itself has a .uv property, and you just give it all of the UVs that you've calculated. All right, so it's not actually very long as to what it's all doing, and it's all happening in this start function for now. So if we just go down and have a look, you can see there's nothing in the update, and there's just those values there. Okay, so switch back to Unity, and we've got those UVs on here now. Now this foundation cube here, with that set UV script on it, you can now set the pixel size, the tile X and the tile Y position. So with 1611, we should get the grey tile on there when we run it. Okay, so you can see now it's gone to the grey, it's picked up that part of the texture atlas. This one has too, because remember that it's by default, that script on here, you can see it's the 1611. Now if we want the grass texture, then it's going to be tile 0 and how many did we have? 16, 15 is it? Just run that. Yep, and there's our grass texture on there. Okay, so if you wanted that, if we go back to our little texture atlas and have a look here, if we wanted one of the, say, sandstone ones, this one here, this would be tile, so this is 0, 1, 2, so it would be 2 in the Y and 0 in the X. And you can try that out back in Unity. Let's go with 0 and 2 here and run it. Okay, so now you've got the sand texture on that cube and the grey one on that. And what's so nice about this is that they're using the exact same material. Now the only thing left to do is to combine the meshes. Now at the point when you do the combine mesh function, it reassigns all of the UVs. So what we have to do before we combine the meshes is keep a log of all of the UVs for the block that's about to be added, add the block, and then put those UVs back, inject them back into that UV array. Okay, so to change this, grab hold of your grey block, or your sand block or grass or whatever you got it set to, which was our cube prefab. This is the one that we're using in our build mesh code to instantiate. Now, if you've changed the UV settings down here, okay, then you might want to hit apply. Now I'm just going to go back to tile 15 on this one so that I get the grass, and I'm going to apply that to this prefab, and then I'll just delete it so that it's not there anymore. So we're back to our foundation block, and we need to update the build block mesh script to get the new UVs and inject them properly into our mesh. So let's open up this code here, and you can see I've already inserted them. So the only thing that's changing in, and I say only, but that's a lot, I guess, in this build block mesh is the combine function and how it's actually operating. Okay, so if we just go down the bottom, this update hasn't changed, it's still the same. Okay, so let's look at combine. Going up the top. Okay, so combine grabs the block that we're about to add, And what it does differently is here, it grabs all of the UVs from the existing mesh, which is our foundation block. Grab all of those UVs. And then what it does is it does the combining stuff as it did before, but then it goes down and it makes a new UV array. Now remember, each time we add a single block, it's going to add 24 new UVs to our mesh. So the size of the new mesh UVs will be the old mesh length plus 24. Right, the next thing we do is copy all of the old UVs into the new mesh, and that will leave 24 at the end for us to now fill with the UVs that are coming from the block that we're about to add. Now, in the next part, I'm actually grabbing hold of the set UVs settings from the incoming block, which is this line here. And you'll notice I'm recalculating the UMin, UMax, VMin, and VMax again. So I'm recalculating those. Now the reason being is that these blocks that you're about to add don't actually exist in Unity for any update cycle. So you aren't guaranteed that that start function has run and reset all of the UV values of that block for you. So and you don't need to do that anyway. So you may as well just calculate what the UVs are that you want on that new block based on the settings you've got of the pixel size and the position of the tile in the texture atlas. And then we go through and we've run in the exact same code that we had for the set UVs script that you can see here. This is the same ordering, but now it's going to put it in the new UVs mesh starting at the position that is 24 from the end, and then plonking all of these new values right onto the end of that mesh so that anything that already exists keeps its same set of UVs, and then this new block that's been added to the mesh will now grab these UV values that you want. Okay, then going down a bit, we then assign all these new UVs to the mesh UV set here. Then we do our other calculations as we've done before, and then add the mesh collider, again, same as before, and set it all back to active, and then destroy the old block. Okay, so that is it. That's all the change is in that combine block. Everything else is still the same. Right, so let's go back here and run it and see what we get. So let's run. So we've now got this grey block coming up, and when we click, we get the grass texture of the new block, and you can't really see it very clearly there. Rotate around. I'll do it in this view here. You can see that the texture from the bottom block is still there. It's kept that grey stony colour, and the grass ones are now being added here. Right, so that's working nicely. The next thing to do is create some more blocks that we can add other than just grass, and test that we're actually on the right track. Now, for a simple way to test these different blocks with the different textures on them, I'm going to create a simple button system where we can change the type of block that we're about to click onto here with these buttons. So let's go first of all to our build block mesh script, which we will just change to accept an array of blocks, which we will set different UVs on with the script set UVs so that we can then designate different textures. Okay, so at the top of the script, we're going to add this public game object array called blocks. We leave the old game object blocks there. That's fine. I think it was public. Doesn't need to be public anymore. It's only going to be used internally here. Then a quick start function which will set new block to something, which will just be the first block in the array. Otherwise, it's going to be nothing, and then you'll get an error if you start trying to build without clicking a button. And finally, just this public void function set block with the number of the block that we want out of the array, and then we'll use that block as our new block. So it'll be the one that's chosen. This function here is going to be run from our buttons. So that's all you need to do, is just make sure that this code at the top of build block mesh is correct. Right, so save that and go back to Unity. Now we need to add some buttons into our game so that we can click and select which block that we want. So in the hierarchy, I'm going to go right click and then UI button. That'll create a button down the bottom here for us. Now, if you don't like the size of that button or you want to move it around, then you can go to the 2D view over here by clicking on that. Let me just zoom out. Now, notice that the GUI view is not at all related to the 3D view, because your 3D scene is right down in the bottom corner. It's really, really tiny in this view, and this button is huge, but they don't actually relate to each other because they're in different spaces. The UI is in the screen space and the blocks are in the 3D world space. Anyway, I'm not going to go into all the details of UI in this tutorial, but we've added this button, and when it adds in, it gives you a canvas that it becomes attached to. Don't worry about that. And an event system also, that's just to accept all the clicks and deal with input. Don't worry about that. With the button selected, you can resize it. I'm just going to make it like that size there. Now let's make this button change to the grass block. So just drop down inside the button, go to the text, and we can change that to grass. Oops, like that, and you'll see it changes on the button here. Now we want this button to activate that code that we just created. So select the button, then in the inspector at the bottom, you've got this on click section where you can add in the events that are going to happen when you click on that button. So let's click on add. Now the code that we want to run is on that foundation block. So grab the foundation block and drag it down into here. That will then expose all of the things that you can run with respect to the foundation block. And you'll see this build block mesh code come up. And over this side, which is slightly off your screen, let me just make this a bit smaller if I can. Yep, and build block, go down the list, and you'll find the set block function. Set block, and then it takes an int as a variable. Now this will then allow you to put what the int is that you're sending through to that function, and in this case the int is the block number in that block array. Now initially we're going to have two types of blocks. We'll just put grass and maybe lava. So when we click on this particular button, we want it to select the 0th block in the array, which will be our grass block. Okay, so let's go ahead. After we've set that, we're going to grab our button and duplicate it with Control D. That will create a new button here. Hit the W key over in the scene, which will grab that other button, and just drag it out. Okay, and you want to change the text for that button to lava. Oh, I keep clicking out of there. You might want to rename these buttons to make it a bit more obvious what they are. So maybe we put this as grass button. It won't actually change anything in the code. Just helps you know which ones they are. If later on you wanted to put an image on these buttons of the actual textures, you can come back and drop those in as these materials in the button settings. But for now, I'm not worried about that. Right, now this lava button was a duplicate of the grass button, which means that it will already be linked to the same function in the foundation block in our build block mesh set block. But this time the lava one is going to be block number 1 in the array, so we can change that there. Okay, so that's all done. The last thing we need to do is actually make our blocks that are going to go into this array, which is on the foundation blocks build block mesh. You'll now have blocks as an array. We're going to have 2 blocks that are going to go in there. The first block is going to be the grass one, and the second one will be the lava one. Now, we've already got a grass block, which was this cube prefab that we created a while ago. And remember, its tiling was 0.15, which gave us the grass texture that was right up the top. And I'll just switch back and show you that. Okay, so it was grabbing this one here. So that was 0.15. Now we're going to grab the lava, okay, which is actually 15.0 because it's down at the opposite end. Back to Unity. So let's just duplicate Control D our cube prefab. Let's call that now grass. And the new one we'll call lava. And we can now set the UVs for that particular lava one, the prefab, to 15.0. Okay. So when that lava runs, it will become lava texture. And we can just check that. If I go back to 3D view in the scene, if we grab the grass and bring it in, and the lava and bring it in, and then just run it. Yeah, so that's the grass one, that's the lava. They change because remember we've got that set UVs code on there that will do that for us. So we can now just delete those out of the scene. Go back to our foundation block to the build mesh script, and here's our array. So we want the grass to be the first one. And we want a lava prefab to be the next one down. Okay, right, the time of reckoning. Let's run this, see what happens. Now, by default, it should be grass that's being added. Yep, then we can click on lava and add the lava, grass, lava, grass. Okay, and I'll just zoom out and you can see what I've built. Not particularly exciting, but you get the idea. So now this is all one mesh with one texture on it. And if we have a look at the stats, they should be quite low, which they are, because it's a lot. You can see the set pass calls down here at 2. See, it's one mesh with one texture on it. It's just that you're playing around with the UVs. So you're going to be able to create a much, much bigger procedural mesh this way than the old block system that we did with the Minecraft. But having said that, what you've done if you followed through all of these tutorials is that you're actually getting your head around the idea of 3D space and the coordinate system of all these blocks before launching into the procedural meshes, because they are a little more difficult when you start playing around with UV values and vertex values. The math gets much more complicated. All right, so that should give you something to launch off from. You can add as many different buttons as you like down here with all those different blocks, and you just have to drag them into that array, increase the array, and assign the button clicks. You could also do it under the keys. If you wanted to set different keystrokes to do the same thing, you could do that as well. And that's it. So I hope you learnt something about UV mapping, textures, texture atlases, and procedural meshes. And let's have a think where we go from here. Good luck and have fun playing with that.